All right, here's the last part of section 1.5 in chapter 1, which is solving absolute value expressions. So let's take a look right at the first one here. We want to find the value of x that would make this true. And so there are two possibilities here. The value inside of the absolute value to get an answer of 6 could be plus or minus 6. So we then say, well, 9 minus 5x equals 6, or 9 minus 5x equals minus 6, and you would solve for x in each, and you would have two number answers. Similarly, with number 2, we would consider, well, what absolute value would equal minus 3? And the answer is no value would get you an answer of minus 3, because absolute value is always a positive result. So the answer here is no solution. So just watch for that, not trick, but expectation that you would recognize that. Question 3, though, is a little different. We have another absolute value equaling 3, and so there's now two possibilities, that it equals 3 or it equals minus 3. And to solve that, we would move everything to one side and equal to 0. Check and see if you can factor it. If you can, great. Use your factoring skills. If not, you might have to use the quadratic formula. Now, when you get to a question where there's variables on both sides, we must consider both possibilities. Just like in the previous question, it equaled positive 3 or minus 3. Here, the absolute value could equal t plus 6, or it could equal negative t plus 6. And if you want to just change both signs, that might be easiest. And again, you just solve for t, and you're going to get two separate answers. With a more complicated expression like this, where we have two absolute values added together, we're going to do the same thing that we did in the previous section. We were asked to write this absolute value to define it. Here we're going to do the same procedure. We're going to take 2x minus 2, and we're going to take x plus 3. We're going to mark the zeros, which in this case will be at 1 and at minus 3, and then we'll do our little sign analysis. And we're going to consider what happens in the three different intervals that we have here. So let's start at the top right. Both of them are positive, so we leave them both being positive. We'd have 2x minus 2 plus x plus 3 would equal 7. In the middle, both of them, oh man, I hate when I screw up like this. Sorry about that. My sign analysis went wonky. So I guess the first part's still right, but now in the middle, the 2x minus 2 has to be negative in order to be positive, so we would put a minus in front of the 2x minus 2, leave the plus in front of the x plus 3, still equals 7. Now on the far left, they both need minuses in front, so just to save myself a little bit of time, I'm going to make them just the opposite sign that they are now. And then you need to solve each, so I'll just go ahead and solve these. We got 3x, that's 1, take away 1 is 6, x is 2. You need to check that this answer is in the interval. It's possible. So yes, 2 is greater than 0, good to go. In the middle here, I'm going to get minus x equals 2 plus 3 is 5, 7, take away 5 is 2. Divide is minus 2 between 0 and 3. Yeah, it's between there and there. That answer is legitimate. And then lastly, here we get minus 3x equals 2 minus 3 is minus 1, add 1, 8. Negative 8 thirds. Well, that is not in the interval less than minus 3, so we would have to reject that answer, and it wouldn't be part of the solution set. Now, the last part here is inequalities, which isn't super hard. You just need to understand the basics of it. So if this absolute value is less than 11, and if we consider the values that would get us that answer, less than basically goes with or. That means the numbers could be, well, less than minus 11, because anything absolute valued less than that, that's not true. This is an and situation. Less than 11 would be between these two, because any number between there, when you take the absolute value of it, will get you an answer that is less than 11. So what we have to do is set up two different absolute values, or two different expressions. Either that's true, and then this has to be true, that at the same time it needs to be less than 11 and greater than minus 11. It's got to be that overlap, and means overlap. And so we would solve those, and we would find where those two answers overlap, and that would be your solution. And the opposite case, which is number 7 here, is the greater than, and with greater than comes your or situation. So if we talk about 21 and minus 21, that the answers could be here or there, less than 21 or greater than 21. So we would say that 6 minus 5x is greater than 21, or 6 minus 5x is less than or equal to minus 21. And you would solve those, and all those answers would be part of the answer, whereas in question 6, you'd have to talk about the overlap because it's an and situation. Question 8, when would the absolute value of anything be greater than minus 4? It's always greater than minus 4 because it's a positive value. And then when we get to number 9, the absolute value of 3x minus 2 is less than or equal to x minus 1. So we go back to here, it's basically the same question as 6. We get that, therefore, 3 minus 2x could be less than or equal to the negative version of x plus 1. And at the same time, 3 minus 2x would be greater than x plus 1. And you would solve those, and again, you're looking for overlap. And then you might get into something really cool like this, and we can talk about that when you get there. If you're having trouble, when would that be greater than 1? And what it's related to then is the value of 5, because it would be equal to 1 at 5 over 5. And so really you're looking at when would this equal plus or minus 5 would be a starting point anyways, and you would have to think about it from there. So that's it. Lots of information, lots of practice, and these questions are probably the most challenging in the unit. You're going to need to ask lots of questions, and we will take it there when you get to that assignment, and I'll be glad to help you.